Hi guys, welcome to Algebra 1, Lesson 39. We have two parts to this lesson, two basic parts. The first is called the trichotomy axiom with negated equalities. It's a big name for something very simple, and I'll show it to you in a minute. And then the second is advanced ratio problems. And these are something that you've already seen before, so we're good to go. All right, let's start with the trichotomy axiom. With the trichotomy axiom, this is basically just saying that if you are given any two numbers, okay, then one of three options has to be true with the relationship of those two numbers. The first is that A equals B, when A is one number and B is the second number. They could be equal, that's one option, or A is greater than B, that's another option, so one number is bigger than the other. Or A is less than B, so that number is smaller than the other. Those are your three options, and it has to be one of those three options. So to show that this is negated, that it's the opposite, we draw a line through it. So if I have this expression right here, this means that x is not greater than 10. This is the sign for greater than, but because we have a slash through it, it means it's not greater than. So if I wanted to write this, showing what it truly is, okay, it's not greater than, that means it's the opposite. What's the opposite of being greater? Smaller, right? So that means that x is less than 10. Oh, but there's more, because there are three options, and I only got rid of one, that x is greater than 10. It could be less than 10, or it could be equal to 10. So I have to represent that by putting a line underneath of my inequality sign. And this is read as x is less than or equal to 10. So I just write the exact opposite. I flip around my sign and I put a line underneath. Let's take a look at this one. Here I have x is not greater than or equal to 6. So if I want to write what it is, well, I've gotten rid of the option that it's equal to and the option that it's greater than. So I'm only left with the last option, that it's less than. So again, I'm doing the exact opposite. I'm flipping this symbol. So instead of having the open end over here, I have the smaller end. X is less than 6. Since I do have the line underneath showing that it's equal, I don't have the line underneath here showing that it's definitely not equal. So this would be read as x is less than 6. If we want to graph these, here I have x is not less than 2. Okay, so I know x is not less than 2, so what is x? Well, I've gotten rid of the less than option, so it has to be one of these two, and I have to express that. Since it's not less than, that means that it is greater than or equal to 2. To graph that, I come over to my 2, and I put a closed circle because 2 is included. And since x has to be greater than, I go this way. Okay? I go towards the right, towards the bigger numbers. So that shows that x is greater than or equal to, I'm going to make that circle even bigger. Show that 2 is included, greater than or equal to 2. Now let's look at this graph, okay? I want you to write both an inequality and a negated inequality to describe the graph. So tell me what it is and what it is not, is basically what this is asking. Tell me what it is and what it is not. Just like this tells me what it is not, and this tells me what it is. So I have an open circle over the 3, and my arrow to the left. Okay, so let's represent the number with an x. And let's start with what the number is. So the number is, well, it doesn't include 3. It is, let's see, well, it goes to the left, so that means smaller. So that means that x has to be less than 3. Not including 3 because it has an open circle. So that means that x is not greater than 3 or equal to 3. So I draw the greater than symbol, the equal to symbol, and I slash it through. Let me do that again so you can see it even better. All right, that shows what it is not. Okay, let me know if you have any questions about that concept. We're going to move on to advanced ratio problems. Some ratio problems are not just straightforward, this is my ratio of red to green, and I have this many red, how many green. Some of them say, this is my ratio of red to green, this is my total, how many green. So when we throw in total, we have to add some more steps. On the bottom of page 151, Saxon gives you 4 basic steps. Number 1, write the information given to include the total. So you write down, for example, red, green, and then your total. So that means you add up the red and green to have the total. Use the cover-up method to write 3 equations. I'll show you what that's talking about in a moment. Reread the problem to determine which equation to use, so to find out what you're looking for. And number 4, substitute in the selected equation and solve the problem. So let's walk through a problem together. The ratio of red marbles, this is example 39.3 on page 152. The ratio of red marbles to blue marbles is 5 to 7. If there are 156 marbles in the bag, how many marbles are red? Okay, so I have, let me just map it out. I know I'm going to have red marbles, blue marbles, and then my problem mentioned a total, so I'm going to include the total number of marbles. Okay? So according to my problem, it says that I have 5 red marbles, 7 blue marbles. So how many total marbles do I have for my ratio? 12 total marbles. Very good. 5 plus 7 is 12. All right. So my problem says if there are 156 marbles in the bag, so that's the total number of marbles, how many are red? Okay, so let's see what ratio I need. I'm looking for red marbles, and I've got total. So I know the total, and I'm looking for red. So that means my ratio needs to include the red marbles and the total. That's what it means by cover up. Cover up what you don't need. I don't need the blue marbles. I only need the red and the total. So I know from my ratio here, my simplified ratio, that I have 5 red in a total of 12. I know that there are a total of 156 in the bag. So from there, I'm looking for the red marbles. Remember, to solve this problem, we have to cross multiply and then solve, okay? So to cross multiply, well, I just want to check one thing in my book really quickly, make sure I'm on the right track. Yes, I am. Okay, so to cross multiply, I cross multiply like that, in the shape of an X. 156 times 5 is, let me do the calculations really quickly. All right, 780. And then we have 12R. We get rid of 12 by dividing both sides by 12. And we get that to be 65 red marbles. So when I have a total of 156 marbles, I have 65 red marbles. Check this by putting 65 in place of R, cross multiply again, and make sure that you get the same number. Okay? Let's try a second example. 39.4, the bottom of page 152. It says, the ratio of fish to crabs in the sea cave was 13 to 4. If there were 119 fish and crabs in the cave, how many were fish? Okay, so this means I have fish, I have crabs, and I have my total. According to my problem, the ratio of fish to crabs was 13 to 4. So that means 13 fish, for 4 crabs. So what would be the total of my simplified ratio? 13 plus 4 is 17. Very good. Then according to my problem, I know that there's 119, total fish and crabs. How many are fish? So I'm looking for fish and I know the total. So that's what I need to use in my ratio. Fish and total. It actually does not matter which one is on the top and which one is on the bottom. I could do total over fish. It wouldn't matter. In fact, let me do that to show you what that would look like. If I did total over fish, I just have to make sure that my numbers match. So the total is 17, the number of fish is 13. My problem says I have a 119 total of fish and crabs, and I'm looking for fish. So you just have to make sure your numbers match. You can't put the total on the bottom if for the first ratio you put the total on the top. You have to make sure both numbers in the numerator represent the same thing, both the denominator represents the same thing. As long as you do that, it doesn't matter which way you put it. So I cross multiply to solve. I get 17f equals, let's see, whatever 119 times 13 is. Let's do that really quickly. You know something? I don't like doing math on the board in front of you. It freezes up my brain. Okay, 1,547. All right. Then to get f by itself, I divide both sides by 17. And that gives me a total of 91 fish. Okay? Solve by putting 91 in place of f and cross multiply again. Okay, so that's how you solve these kinds of problems. Let me know if you're confused at all before you start your practice, but go ahead and do your practice really quickly. Okay, you should be back, ready to go. Letter A, you should have gotten that the total number of games when your ratio of wins to losses was 3-2, it would have been 39. 39. Letter B, how many games they won would have been 39, excuse me. All right, letter B, you should have gotten, for the easy problems, it was 217. And for letter C, you should have a closed circle over 5 with an arrow to the right, so towards more positive numbers, because x is greater than or equal to -5. So closed circle over -5, arrow towards the right. Letter D, you should have x is greater than -2. So that would be an open circle over -2 and an arrow towards the right towards the positive numbers. All right, that's it for today. Have a wonderful day. Let me know if you have questions. Bye.